The task was to design and construct approach structures and a cable-stayed bridge spanning the 900-metre-wide Rambler Channel between Ting Kau Headland and Chinyi Island. An 1,177-metre-long cable-stayed bridge with 2 main and 2 side spans supported by 3 slender, single-legged towers. To withstand the extremely high wind loads encountered during typhoons, cross struts below deck level and transverse cables were introduced to give the towers the required lateral stability. 2 separate decks on each side of the towers contribute to the slender appearance of the bridge, while acting favourably in heavy wind conditions, with design wind speeds of up to 95 metres per second. The island was then formed by placing more than 500,000 cubic metres of rock and sand fill. Its location took advantage of a high point in the underlying rock formation, which reduced the quantity of fill that would otherwise have been required. After completion, the island provided protection against potential ship impact and lateral stability to the tower foundation, while acting as a working area for the piling operation and construction of the pile cap. 52 piles with a diameter of 2.5 metres and an average length of 27 metres were excavated by grabs inside temporary steel casings. Prefabricated reinforcement steel cages were then lowered into position and the piles concreted with tremie pipes to 3 metres below the surface. After completion of the piling operation, fill material was excavated within a 35 by 40 metre sheet pile enclosure, which marked the outer limits of the pile cap. The pile heads were trimmed using jackhammers and breakers. For the construction of the pile cap, 1,300 tons of reinforcement steel were fixed, including 12 layers of bars at the bottom and 9 layers of bars at the top. The weight of these bars required temporary steel frames to be installed as supports. Concreting of the 5,800 cubic metre pile cap was carried out in one single pour. In a 75 hours non-stop marine operation, 4 barges ferried some 820 truckloads of concrete across the channel. The large volume of the pour necessitated the use of chilled concrete and the installation of 700 metres of cooling pipe, through which water was pumped to control the temperature development in the concrete. For 3 days, trucks rolled on and off the island in ponderous succession, accompanied by the endless sound of pumps and vibrators. By dawn of the 3rd day, what was at the time the largest single reinforced concrete pour in the history of Hong Kong was successfully completed. In slip forms. In this method, concrete was poured into steel shutters, which were continuously raised with hydraulic jacks operated from a central control panel. Slip forming with high-strength concrete progressed at a rate of up to 4 metres per day. The towers, rectangular in shape with semicircular sides, were formed in 3 vertical sections of decreasing plan area, separated by transition slabs. At each of these transition slabs, the slipform assembly was dismantled and replaced by conventional curved shutters. This facilitated the fixing of up to 335 tons of reinforcement steel per transition. The up to 8-metre thick slabs were then cast in the conventional manner. Slip forming for the remaining section of the tower continued by night and day. A pathway was marked out for the multi-wheeled flatbed hydraulic trailer to carry the tower head to the exact position at the base of the tower where the lifting gear would be attached. On the Ting Kau side, the tight space between the tower and an adjacent rock face required additional movements before lifting could commence. Using the rear section of the trailer and the heavy lifting gear, the tower head was inched to the vertical, ready for its stately ascent to the top of the tower. Once the tower heads had reached their final height, they were slid inward into spaces left open for them. There, all elements of load transfer were installed, and the remaining tower section was concreted directly against the tower heads. To arrive on site were the 2 starter panels for the Ting Kau Tower. These vast assemblies, measuring 23 by 16 metres, were offloaded from the barge by night when sea conditions were calm. Even then, extreme care was necessary. The limited space at the base of the tower required that the grid be transported in the vertical position. Dubbed the rocket launcher, a 20-metre steel frame mounted on a pair of hydraulic trailers held the grid, as the assembly made its snail's pace approach to the lifting position. By dawn the next day, the heavy lifting system on top of the tower had lifted the 60-ton panel into position some 70 metres above the ground. The panel was then pulled inwards to engage hinges temporarily attached to the tower. Over a period of 3 hours, the panel was lowered into its final position, joining its previously installed twin on the other side of the tower. Following the erection of the starter panels and the lifting of the steel cross struts, transverse tower stabilization cables were installed between the lower transition slabs and the cross struts, and from there to the tower heads. Like the mast of a sailboat, the slender tower now has the required stability to cope with high wind loads. Precast concrete deck panels, 4.5 metres square, were placed onto the steel grid of the starter panel to complete the first segment of the composite deck. In a typical grid, 12 such precast panels were placed and the joints concreted to give the segment its composite characteristics. Many hands make light work. Well, sometimes. Manhandling the high-density polyethylene sheath for the stay cables was certainly labour-intensive, but it was also an excellent boost for the team spirit. The deck stay cables consist of up to 58 strands of 7 galvanized wires. Each of the strands was individually installed between the dead anchors at deck level and the stressing anchors in the tower heads. Using a wheeled detachable trolley which prevented chafing, each of the strands was pulled up inside the sheath. The sheaths have an external helical protrusion which reduces rain-wind induced vibrations of the cable. Within the tower heads, each of the strands was stressed by isotensioning. And the derrick cranes were moved forward, ready for lifting of the next grid. adjacent to the two side towers. At a length of 465 metres, they are the longest stay cables ever installed on a bridge. Shorter side spans, rocker bearings were installed to give vertical support to the bridge decks while allowing thermal expansion and contraction.